So you want to be a robotics engineer. After all, crafting intelligent machines to benefit humanity in ways we can't even imagine is a pretty awesome career. Let's unravel the mysteries of robotics engineering and explore this dynamic field. We'll look at the technologies that they use, their sizable compensation, the subtle secrets that make it so intriguing, and much more. It's time to discover what it means to be a robotics engineer and give it to you straight. This is the reality of robotics engineering. Let's start with defining what a robotics engineer actually is. These engineers use a wide range of software, electrical, and mechanical engineering skills to design everything from your average Roomba to Perseverance, the Mars rover seeking signs of ancient life 140 million miles from us. Which is pretty damn cool. But what exactly is a robot and how does it work? Great question. A robot is a programmable machine that can execute physical tasks with speed, precision, and little to no human intervention. They work by taking in the environment around them with different types of sensors. From there, an internal control system decides what to do with the sensed data and then sends signals to actuators to physically move the robot and achieve a task. Let's take the life-saving bomb squadron robot for example. First, this robot takes in its environment with an array of sensors. It has cameras to see the area, gas and radiation detectors to identify potential threats, and laser rangefinders to accurately measure distances. There's also a human interface so the bomb squad can manually control our life-saving robot. All of these inputs are considered by the decision-making control system that in turn decides which actuators to stimulate. So when the controlling human sends a signal to pick up a suspected bomb, the control system is the one that activates the actuators that bend the arm down to grasp and pick up the explosive. Now if you think that's cool, then just wait until we deep dive into the robotic systems hidden in a world-famous Tesla, highlighting how robotics engineers bring such a remarkable feat of technology to life. But before we get there, we need to take a look at the Robotics University curriculum to find out how these engineers gain the diverse skill set that allows them to design such futuristic advancements in the first place. Now there are a few university paths that typically lead to a career in robotics, but the most obvious is either a robotics or mechatronics degree. In case your college doesn't offer these, any electrical, software, or mechanical based degree will work just fine to get you into robotics. Remember that this field was forged from those three. Now before we get into the robotics curriculum, remember that each school does things a little bit differently, but the ideas and concepts here will ring true for any robotics degree. Now getting right into it, the early stages of the curriculum does not surprise us with a strong base in physics, math, and computer science, much like the other engineering fields we've covered. Getting deeper into the robotics degree, we see the real fun stuff. Circuits courses get students prepared for all the electronics that are the heartbeat and veins of our robots. Students will cover the basics of DC and AC circuits, passive and active components, and how to design and test circuits for any application. But robotic circuits would largely be expensive bricks without the software that controls them. In their software courses, students take object-oriented programming, data structures and algorithms, and microcontroller and embedded system programming to get them up to speed with ever-important robot controlling software and related hardware. Now that the hardware and software are taken care of, it's time to talk mechanical. Students will take an array of statics, dynamics, and mechanical systems design courses so they're able to generate the machinery that gets robots moving. And now that the students covered all the main basics, they're ready to move into the true heart of robotics. Here in the Thriving Center, students explore a variety of robotics manipulation, industrial robots, and mobile robots courses. Focusing on application rather than theory, these students dive into everything from cost justifications and production problems to the actual step-by-step design of robotics. When designing, students use a vast array of technologies, from mechanical modeling to circuit design software and various programming languages and techniques. These students end up with a packed resume by the time they're done. From here, students have the option to specialize. Some choose to stay broad, simply focusing robotics applications in one of the three core areas, whereas others decide to specialize directly within a robotics subfield like robot vision or autonomous vehicles, which will take them right through to the end of the degree. Now, of course, there are other important math, physics, and engineering courses with varying levels of real-world applicability for the career, but the ones we just covered are pretty much the must-haves for robotics. If you want more information, check out our computer and electrical roadmap videos. And now that we understand the robotics curriculum, it's time to explore a real-life robotics engineering design through the industry-leading Tesla electric vehicle. As a disclaimer, we've simplified the details a touch for the sake of the video, but as always, all of the core concepts hold true. Now let's get right into it. This tech giant all started with Tesla founder Elon Musk recognizing a growing market for electric vehicles as society began to take climate change more seriously. Although the $750 million company relies on mechanical aspects at its core, the robotics systems is what makes the car stand out on a global scale. The sensors are always a great place to start, and boy, do Teslas have a lot of sensors. But the really impressive part here is how robotics engineers tie them together with sensor fusion. This is actually how autonomous driving works. Let's explain. First, you take all your sensors: radar to find the position of nearby vehicles, video camera that track traffic lights, road signs, and other vehicles, and LiDAR sensors that bounce pulses of light off the car's surroundings to measure distances, detect road edges, and identify lane marking. Next, you compile all of this data and fuse it together with complex algorithms, machine learning systems, and state-of-the-art multi-core processors. This intricate procedure is what we call sensor fusion. The processor has figured out the car's surroundings and is now able to make the decision whether to brake, accelerate, turn the wheel, or activate any one of the many other actuators. Which is great, but what are robotics engineers actually doing to make this all happen? Well, on the front end, many engineers are working to find or design cameras, LiDAR, radar, and other sensors that can take a wide enough picture of the car's surroundings and sense the data fast enough. This process involves all type of electrical and computer engineering practices like traveling electromagnetic waves and reliable data transfer. We also have mechanical aspects here, namely designing the camera housing and integrating it into the car's chassis. Robotics engineers have their hands full when it comes to the actual sensor fusion. There are hours upon hours of signal processing and machine learning to successfully integrate all these different technologies to make a potentially life-saving decision in a moment's notice. The heavy lifting of this sensor fusion is done by software and machine learning engineers, but hardware engineering is also necessary to integrate the best processors for the job with all the various peripherals around the vehicle. Finally, mechanical and electrical based engineers design all of the actuators from the steering wheel to the turn signals and help integrate them all together with the output of the processor, which gives you a good idea of not only the thought, persistence, and innovation that goes into a robotics design, but also just how awesome one can be. And hey, if you happen to hatch that next multi-billion-dollar robotic system, don't forget which awesome YouTube channel helped you along the way. Now, before we wrap up, we know you want to hear about some dollar signs. How much do robotics engineers make? For the immaculate and rewarding work that they do, robotics engineers get paid around $122,000 a year on average, substantially higher than the average engineer at about $104K a year in the States, according to Glassdoor. Compensation aside, robotics engineering is a growing and fantastically interesting field that blends the efficiencies of software and machine learning into the discrete atmospheres of hardware and mechanical engineering. Now, with all of this in mind, do you want to be a robotics engineer? Let us know in the comments below. Want to know why students decide to enter mechatronics instead of robotics? Check out this video. Thanks for watching, and happy engineering, everybody.